Okay, so here are the notes for section 12.4, volumes of prisms and cylinders. Excuse me. We've talked about surface areas of prisms and cylinders. Now we're going to talk about volumes of these shapes. So first of all, the kind of basic introduction into how to find the volume of a prism. Basically, it's a figure where you have a shape. Two sides are parallel, and then you have sides that are also polygons. The key to it is realizing that what you're asking for is how many cubes fit in there. So if you were to think of like one level, like let's just think of the top level here, highlighted in green. You have this level here we're talking about. Okay. Well, in that level, there are, if we just think about squares for a minute on top, there are 6 by 4 of those guys. It's 6 wide, 4 deep. So there are 24 squares. But if I think of it as like a thickness now, there's 24 cubes there. And then this happens at a second level, so it's 24 times 2. Okay. So it's the area of the base, how many squares are on the base, and then the question is how tall is it? That'll give you your volume of 48 cubic units. So first formula here is volume of a prism, area of the base times the height. Now notice, this is really, really important here. Notice that this base here is capital B. Okay, we've talked about that a few times, but it's area of the base, not a base length. So don't get caught up in that. Like, well, B is the base for the triangle. It could be, but we're talking about area of the base here. Now, the next thing I'm going to talk about then is how does this work for a cylinder? So what is it? What happens for a cylinder then? Well, you can think of a cylinder as an awful lot like a prism. Okay, the only difference is for the cylinder, and excuse my terrible drawings here. Oh, that's bad. Oh, I can laugh at it because it's just sad. But that's a circular base there for that cylinder. It's the same idea. Find the area of the circle on the bottom and then fill it up. And then what level are we filling it up? Are we going to this level, or in this case, it's all the way to the top. So volume of a prism is area of the base times the height. Well, the shape of the base for a cylinder is a circle. So the area of a circle is pi r squared times h. So this formula specific to a cylinder is pi r squared h. So volume of a cylinder, the volume is area of the base times the height, but really the base is the shape of a circle, so pi r squared h. Right. So first example, find the volume of the prism. So yeah, have a question pop up there for you. What's the volume of this prism? And then there we go. So the key to this is really identifying the base. And that always tends to be the problem with this, is that we want to say the base is the shape it sits on. But remember, the bases have to be parallel. And there's a rectangle on bottom, but I'm not parallel to that rectangle with any other rectangle. It's the triangle. That is the base of the polygon, because those two sides are parallel. The triangle and the triangle. The 25 is the height, because that's the distance between the bases. Okay. So, for the volume, area of the base times the height. Well, the base is a triangle, so it's 1/2 base times height. So for us, the base length is 10, the height of the triangle is 12, so 1/2 10 times 12 gets us 60. The height then, like we said, is 25, so the volume is 60 times 25, which ends up giving us then 25 times 60. I think 1500. Does that seem right? I'll get my calculator out here. 60. 25. Yeah, 1500. Yeah. So 1500 cubic centimeters. There we go. Now, for the cylinder then, find the volume of the cylinder. It says to the nearest tenth. We'll do both pi in terms of pi and nearest tenth. Okay, so here we go. Formula for volume of a cylinder. is pi r squared h. Well, the radius is 8. The height is 5. So pi times 8 squared times 5 is 320 pi, okay, centimeters cubed. But then, if I want to know what that is in terms of pi, or 10 to the nearest 10th, whoops, wrong button, 320 pi. So 320 times 1005.3. 1005.3 cubic centimeters. Okay. All right, now the next idea here, oh, sorry. Okay, the next idea here is actually something that's kind of, I'll show you a better, in class, a better example of this because I can kind of show you hands-on. But this is called Cavalieri's principle. And the idea is, it doesn't matter. Now, for surface area, this does, but for volume, it doesn't. It doesn't matter if this guy goes straight up or slants off to the side, because the volume will be the same as long as the base area is the same and the height's the same. And the reason it is it's just what's happening is kind of like you're just taking this tower and just tilting it over to the side. It's kind of pushing on it this way. And then you get to just tilt this way over here, and each cross section was still a square, was still a rectangle that had the same area, and it was still just as many of them. It just kind of angled over the side and stays the same height. So in class, I'll have a much better like kind of way to show you this in class, but this is one more thing to bring up in this section is Cavalieri's principle that states that all that matters for volume is cross-sectional area and height. Doesn't matter if it's tilted or not tilted. Okay. Now last problem here. Gonna find, we have prisms A and B, and they have the same width and the same height. So, but they have different lengths. And the volume of prism B is 128 cubic inches greater than the volume of prism A. So the question is, what's the length in each prism? So there we go. All right, so let's take a look at this example. Okay, so the volume of prism A, I'll call it V sub A, okay, is area of the base times the height. Well, the base is a rectangle, so it's 4 times x times 5. So it's 20x. The volume of prism B is 4 by x, but it's 9 high. So it's 4x times 9, which is 36x. Now, the thing is, volume for prism B is 128 cubic inches greater than A. So what that means is 36x is 128 more than 20x. So the question is then, what would x have to be for this to work out this way? Well, we have a pretty easy linear equation to solve. Subtract 20x. We get 16x equals 128. Divide by 16. X equals 8. That must have been 4 by 8 by 5 and 4 by 8 by 9. And I could check that real quick. I feel like doing that in the calculator. 4 by 8 by 5 is 160. 4 by 8 by 9, 288. So 288 minus, whoops, not times, minus 160. Uh-oh, hit the wrong button. Cancel. Cancel, yeah. Minus 160. 128 apart. Okay. There you go.